Good evening, everybody. I didn't get a chance to sign up on the Google Drive before it was closed on the docs, so I chose two topics: drones and machine control or automated control systems. This is it's a combination because I do earthwork. I work for a local heavy civil site work earthwork contractor in the valley, and we use drones and machine control all day, every day. But really they go hand in hand. It starts with the machine control or the automated control systems, but then the back end of that, what my job is as a project manager, has everything to do with drones. So let's get into it. So I just wanted to give an overview, kind of, so that we could set the stage, so that I could set the stage rather, on what we're using these. We do 70%. Let me rephrase that. Up until this year, 70% of our business was residential subdivisions. So greenfield subdivisions, we're putting in utilities, roads, subgrading for lots, and then the home builder will come and then continue to go vertical. Something like this is a lot of what we do. This is in Eagle Mountain where we're doing a lot of work right now. You can see that roads are subgraded. We have utilities in, topsoil stripped off. You can see scrapers in the top right corner, and we're connecting. This is obviously a continuation of a phased project. Same thing you can see in this project. Because we're cutting everything, we went ahead and did the sewer first without stripping all the topsoil off. But you can see our sewer trench and the laterals as well. Let's through some of these. So the first thing that we use, and this is kind of a precursor. This is more related to some of the GIS stuff, but it's a precursor to the machine control. When we're doing a takeoff, we're using a program like Insight Site Work to model things. Obviously, when you're given a grading cut fill map, and they teach you in BYU in this program, kind of the old school method, which is to do it on a paper takeoff. That's not accurate. It's not how we do it. If you're doing long highway work, you could use a mass haul diagram, but that's really the only specific situation that you would use anything on paper like that. Everything else is done in 3D. So we're taking the 2D grading plan, and we're creating something like this, which is a cut fill map using existing and proposed contours and then overlaying them. The computer will overlay them. We'll generate a cut fill map. Red is cut and then blue is fill, obviously, and then the darker the shade, the deeper the cut or fill, respectively. And so like in this, you can see that there's quite a bit of cut, but then we flop quite a bit of cut over here on the bottom left, but then the rest of the site's kind of a fill. So hopefully the site would be close to a balance. If you zoomed in, obviously I don't have the zoomed in view here, but if you zoomed in, each of these little squares would kind of give you like a rough approximation of, in that square, how deep is my cut or fill, to give you an idea as what the scale is. You know, obviously a 30-foot cut is going to be different than a 5-foot cut, and the equipment that you use and the procedure that you use. So then that rolls into our GPS. Once we've done the takeoff, once we've bid the job and then won the job, we're going to begin creating a model. Those models are built on the same programs, and then we will then export those into the GPS equipment that we have. We have 3 dozers at my company, at least. We have 3 dozers, 6 graders, 2 trackers, and 2 scrapers that are GPS controlled. Everything else is manual. We use GPS on 75% of the jobs, and that's mostly just for big job, for size, right? On a really small job, we're not gonna use GPS. It's not worth it. It's very expensive. Excuse me. It's very expensive and time consuming to set up and to run and to operate. And so if it's on a small job where we're doing kind of like a one-off thing, we're not going to take the time. And then we often, if it's only a pipe-specific job, we won't use GPS on that as well. If we have the GPS capabilities out there already, we can use it to lay pipe, and it's pretty slick, but that's not something we will do on a regular basis. So we also use it for footings. We're constantly digging footings, and when you have a 200,000 square foot tilt up with all of the spot footings around, they're getting laid out by a building surveyor, but it's much faster for us to work off the model for both depths, widths, overdigs, all of that. We build it into the model, into the footing model, and then we have a GPS track out that will grade it exactly where we need it to be. It's so much faster than having a grade checker in the footings, and we still have a grade checker that works with those for a backup. But where typically you have a non-GPS track code that's digging these, you're measuring, you're with the laser level, you're pulling the tape, you're spray painting, you're doing all these things. With a GPS track code, it's all operator driven, and so that makes it super fast. Obviously, the dozers and graders need no introduction on GPS, right? If they're finished grading, we want to have GPS on it. There's no reason that we shouldn't have it on it. And scrapers, same thing, but that's much more of a rough. We have plenty more scrapers than 2, but if when you get to 10-foot cuts, scrapers are you just tell scrapers just run, and then when they get close, they'll have the finished dozer come in and check the grade for them. So this is kind of some of the steps to the model, right? We go from a 2D plan to a cut fill map, to eventually a CAD file that we can export straight into the machines. Each machine is obviously different, right? Some Komatsu equipment runs Topcon, and CAT runs different types of GPS. We run a lot of Komatsu equipment, and we run a lot of CAT too, but Topcon works on both. So this is up here. You can see we have 2 views of a different footing model, right? We have the 3D version that includes some cut and fill. It's got some basements in this particular, and then this is how it looks on their model. Because the computer, the actual GPS computer in the, excuse me, it's 11:45 at night, so I apologize for that, but this is what it looks like on their screen. Obviously, running something like that on a small handheld device inside of a Traco is going to be, it's bulky, it's slow, it's not efficient. The touch zoom is not like your iPhone. And so running something like this is just so much cleaner. This is the screen that I was talking about. Really what's happening here, people say, oh, if it's got GPS, I can run anything. That's true. You still need to know how to be able to run the piece of equipment, right? If you've never run a Traco, getting in it, even if it has GPS, is going to be a little bit complicated if it doesn't have automatics, because there's GPS and then there's also automatics. In this case, on this particular machine, it's not automatic. So you're still running the grader up and down, left and right, can't or not. But you can see you got to come down 195. And then this particular place, there's no slope. Your blade's not on slope at all. So that's a big deal, to know that, hey, I still got to come down 2 feet, but it doesn't necessarily do all the work for you. And then we roll into the drone. This is something we use the drone. I'm flying. We have a dedicated GPS and drone guy who's building our models and flying our sites for us so that we can generate cut fill reports. I'm generally on big dirt jobs. We fly every 2 weeks. On smaller dirt jobs or dirt where we're not moving so much so quickly, we're flying monthly for our billings. So that we can get accurate quantities, but this is kind of an example, right? This is just a picture like you would take if you were a hobbyist drone pilot, on a subdivision that I built in Eagle Mountain. This is called Ochre Mountain, and you can see the cul-de-sac at the top. You can see all the pipe and equipment in the middle, but then the drone from that view takes all of this. One thing that you need to notice, and is kind of interesting, in this picture you can see the scrapers and the pipe piles or bunks in the middle, and then you come over here where this is basically like a topography map. You can see all these little lines in here. Our drone operator, when he gets back to the office, he'll take all of those out using the picture overlay. He'll say, okay, that pile is a pipe, that pile is an equipment, because otherwise it will just bounce off that surface and just count it as a dirt pile, throwing off your cut fill quantities. So that's something to keep in mind as well. From that, we generate a cut fill map, and so you can see that this animation is on that same job in Eagle Mountain that I was over. You can see we started at the beginning, which is the dark reds and blues, and successively with each drone flight, you can see what we're cutting out and what we're filling, right? If we focus on this site, you start here, big fill, less fill, and then, okay, we got it filled. These areas, this one, no, those three, 1, 2, 3, were big rock areas. We actually ended up breaking them out with hammers, and then ripping some and then hammering the rest. And so that's why those 3 areas were A, the last, and then B, the slowest. Same thing, 2 pictures back to back. It's good to know for, owners like this. They like to be able to see their site. They like something tangible. And so to say, hey, here's our road subgrade. Okay, hey, we've paved. You can see they've started to pour some lots. And this is it's a really good feature. And then obviously we can overlay it with our CAD files. So you can see each of the lots are individually marked in the CAD file. And so let's just say there was some soil remediation that needed to happen up here. You would know exactly where back of lot is and front of lot is. We still stake those. For, again, redundancy, even though we trust our models, if the stakes and the survey represents what's happening in the model, it's just another way to double check that. Same thing. This is how it looks when you get it in a picture, right? They took this picture rather, and the drone. Now he's going to export that. Using some of this software. So here are some of the benefits and drawbacks to GPS, right? The accuracy is both a benefit and a drawback. People think that, or owners particularly think that we can get, this close on a grade. When you have, particularly in rocky soils, where you're constantly kicking up 2 to 6 inch rock, you can basically just assume that your accuracy is going to be within 2 to 6 inches. If you had a sandy field, you could probably get, we generally say, hey, we'll get you within a 1/10. Obviously, the rockier it is, the less accurate we can be. Grading boulders doesn't really work like grading sand. It's a much different surface. So that's both a benefit and a drawback. Generally, people expect a much tighter tolerance than we can actually give than is realistic. There's greater predictability. You no longer have so much operator error. You can kind of put a less experienced operator in, and he's going to give you a similar result to a more experienced operator, although it may not be as fast. But either way, both operators are going to be faster than without GPS. The vertical integration is nice from the office to the field and then back to the office. With all this drone and GPS, we're constantly exporting and importing, and it means that we are obviously verifying and then estimating what's left to bill, what have we done, and then from that we can figure out what's our actual cost per yard, imported cost per ton, what have we actually filled, have we gone over the budget, are we filling more. The drawbacks are we do have an over-reliance. People are less interested in learning how to grade really well because they're saying I have GPS. And then there's a lot of back-end setup, right? We have a full-time 50-hour-a-week GPS drone guy. That's all he does is fly and build models, and then he's constantly tweaking them, changing them. Anytime there's plan changes, he's got to adjust the model and then re-export that into the machine. So that's if you're a small company, and that's not really that feasible. So that's something to consider. Obviously, we touched on the higher expectations, and then it is error prone. Technology, your phone's error prone, just like a GPS is. So just real briefly, I'm going to run through this job that we started just really quickly. We had 135,000 yards of dirt to move. We averaged 6,200 yards a day. Our best day was 12,420 yards. The running average for K-Tech scrapers was 9,400 yards, and then these are some of the wins and losses. But then we went from this is our original existing cut fill map, and then you can just see, we'll just kind of move quickly. This first flight, we went from existing, the first flight was April 25th of last year, and then we're into June, so about 6 weeks, and we moved all that dirt and got to pretty close. You can see building subgrade, parking subgrade, really close. Has some wall fill areas and some retaining wall cuts. But overall, a super smooth process, and made possible only through GPS and drones. And for that reason, I did those hand in hand, because we wouldn't have this data without drones, and we wouldn't have done this job without GPS. So thanks for watching.